like this video, please subscribe and share it. Don't forget to like it. Now I am going on. Topic is matrices and determinants. Now your first one. Let A, B and C be such that B plus C not equal to 0. If A plus 1, A minus 1, det of this one plus this one equal to 0, then the value of n is, okay, now here det of this one, det of A plus 1, A minus 1, minus B, B plus 1, B minus 1, C, C minus 1, C plus 1. Okay, now here minus 1 power n is there. Every row have minus 1 whole power n is there. Now minus 1 whole power n is common from R3. Now here A plus 1 R1 as it is, B plus 1, C minus 1. Now A minus 1, B minus 1, C plus 1. Now minus 1 power n, minus 1 whole square, now here plus A. Now here minus 1 power n, minus 1 power 1 means minus B and C is equal to 0. Okay, now here next one, det of A is equal to det of A transpose. Now det of A is equal to det of A transpose. Now here minus A, now A plus 1, A minus 1, minus B, B plus 1, B minus 1, C, C minus 1, C plus 1, plus minus 1 whole power n. Now here A plus 1, B plus 1, C minus 1. Now A minus 1, B minus 1, C plus 1. Now A minus B, C is equal to 0. Now here det A is equal to det of A transpose. Now here C1 and C3 interchange. C1 and C3 interchanging. Now here minus is there. Now C1 interchanges C3. C1 interchanges C3. Now C1 interchanges C3. Now det of A minus B, C, A plus 1, B plus 1, C minus 1. Now A minus 1, B minus 1, C plus 1. Okay, now plus minus 1 power n, and here also any two rows in determinants, any two rows or columns are interchanges, sign will be changes. Now here minus is there. Now det of here C1 interchanges C3. C1 interchanges C3. Now det of A minus B, C. Now and A minus 1, B minus 1, C plus 1. Next A plus 1, b plus 1 c minus 1 is equal to 0. Okay, now again and C2 and C3 interchanges. C2 and C3 interchanges. C2 and C3 are interchanges. Now again will be minus is there. Now minus 1 into minus 1, minus 1 whole square. Okay, det of a plus 1, a minus 1, minus b plus 1, b minus 1, c minus 1, c plus 1, plus, now again C2 and C3 minus is there, minus 1 whole square means minus 1 power n plus 2, now det of a minus b c, now a plus 1, b plus 1, c minus 1, now a minus 1, b minus 1, c plus 1 is equal to 0. Now both have same values there. Now here common 1 plus okay, 1 plus minus 1 power n plus 2. Now det of a plus 1, a minus 1, minus b plus 1, b minus 1, now c minus 1, c plus 1 is equal to 0. Okay, now here this value, now here n is any odd integer means minus 1 plus 1, that value is 0. Now that value is equal to 0. Therefore, now here det must be equal to 0 means det of this value must be equal to 0 means here n should be any odd integer. Therefore, here n is any odd integer. Any odd integer. Okay, any odd integer means now you take 1 plus 2. Minus 1 whole cube means minus 1 plus 1 0. That value is equal to 0. Therefore, now here n is any odd integer. Third one is the correct one. Next one is if omega not equal to 1 and omega is a complex cube root of unity and a matrix H is equal to omega 0 0 omega, then H power 70 equal to, okay, now H is equal to omega 0 0 omega. Now H square is equal to omega 0 0 omega into omega 0 0 omega. Okay, now omega square plus 0 omega square. Now 0 omega square 0 0 omega square. Next H cube equal to omega square 0 0 omega square into omega 0 0 omega. Now omega cube 0 0 plus 0 omega cube 0 0 omega cube. Okay, similarly h power k is equal to h power k is equal to omega power k 0, 0 omega power k. Now h power 70 equal to, now h power 70 is equal to omega power 70 0, 0 omega power 70. Okay, omega power 70 can be right. Now omega, now 70 divided by 3 means, now omega cube power 23 into omega 0. Now 0 omega cube value is 1. Now omega is a complex cube root of unity means omega cube is equal to 1. Omega cube value is 1. Omega cube value is 1. Now omega cube power 23 into omega 0, 0. Omega cube power 23 into omega. Now omega 0, this value 1, omega 0, 0 omega is equal to omega 0, 0 omega. Omega 0, 0 omega means that value is equal to h. Therefore, option 1 is the correct one.